Now look at the right side of this equation. Sine function has an argument 1 by h cross integral x to x2 p dx prime plus pi by 4. On the left side, you can have this term integral x to x2 p dx prime plus pi by 4. But this is minus. So if I can have a minus pi by 4 here. I can take minus sign common from this term and pi by 4 to make overall minus of this term plus pi by 4. That is exactly identical with this one. So let me add and subtract a pi by 4 here. So this will give me plus pi by 4 exactly behind this minus sign, and say minus pi by 4 exactly or immediately after this integral p dx term. Now this may be written as say 1 by h cross within the argument. Yeah, of course I'll take a1 to the right side for this step. What remains is sine of 1 by h cross integral x1 to x2 p dx prime. I have a pi by 4 here plus pi by 4 here, making it say plus pi by 2. Minus is taken as a common factor for this term and this term to make it overall minus of 1 by h cross integral x to x2 p dx prime plus pi by 4. That's equal to a3 is already there, a3 by a1 sine of 1 by h cross integral x to x2 p dx prime plus pi by 4. Now this equation is of the form sine of an angle, a constant angle, because integral x1 to x2 p dx prime will be a constant as it is over say one half of a complete oscillation. If I am start counting the oscillation at this point, from this point to this point, it's half an oscillation, and once it return back, it will be completing the oscillation. So from x1 to x2, I can have this integration over half of the oscillation or half of the period as long as time domain is concerned. So this is overall sine of a constant angle. Say I will write it say sine n pi because there is no change for the function, and from my +2 knowledge I know that the function will be changing from sine to cosine or vice versa, or from tan to cotangent or vice versa, or from cosec to sec or vice versa in the odd multiples of pi by 2 and in even multiples of pi by 2, or say or the integer multiples of pi. There is no change for the function. I have sine function on the left side as well as on the right side, so this might be an integer multiple of pi. N pi minus theta is equal to, of course there is a constant on the right side, I have a constant part, into sine of this angle say theta. This is what you call the reduction formulae for theta, or reduction formulae for pi minus theta, and this equation resembles this fundamental equation in trigonometry. So I need to be take care of what is to be written as the format of the equation. So this is of the form sine of n pi minus theta equal to some constant into sine theta, and this constant must turn out to be a power of -1, because in some quadrants the sine function will be negative and in some quadrants sine function will be positive, and the only scope for this constant needed to be -1 raised to a number. And this reduction formula is nothing other than that for n pi minus theta. We know that sine of n pi minus theta equal to -1 raised to n minus 1 sine theta, where n start from 1 only. However, I have a general expression for sine minus theta which is equal to sine theta. If I am interested, I can incorporate that also by modifying this equation. So when n is equal to 1, this is sine pi minus theta. Sine pi minus theta is an angle falling in second quadrant, and in second quadrant all except sign are negative, so sign is positive. That is why I can have say minus 1 raised to 1 minus 1, that is 0. Minus 1 raised to 0, which is 1, that is the constant part, sin theta. When n is equal to 0, here also this is satisfied. When n equal to 0, this is sin minus theta, that's equal to minus 1 raised to 0 minus 1, that is minus 1. Minus 1 raised to minus 1 is minus sin theta. But I'll be writing it more conveniently starting from n equal to 0 if I put this from say n plus 1. So instead of using the reduction formula for pi minus theta as such, I'll be making use of the reduction formula for pi minus theta with the coefficient being say n plus 1. Sin n plus 1 pi minus theta is minus 1 raised to n sin theta. When n is 0, this is sin pi minus theta equal to minus 1 raised to 0, which is 1 sin theta. So this is also true. Let me make use of this equation because this will give me values starting from 0 onwards. This value 0 is also significant. That will give you a wonderful result towards the end of this discussion. And this is a very fundamental result in quantum mechanics, which is different from that in classical mechanics as well. So that is why I'll be making use of this one. So comparing this equation with this standard equation, I have sine function and this part should be identical with this angle n plus 1 pi minus theta. So theta correspond to this one. Theta will be there on the right side as well. So clearly a3 by a1 is nothing other than minus 1 raised to n, and this part should be equal to n plus 1 pi. So a3 by a1 is minus 1 raised to n. Now I am interested in this one. That will give me some wonderful results. 1 by h cross integral x1 to x2 pd x prime plus pi by 2. Okay, let me take plus pi by 2 to the right side. So this quantity equal to n plus 1 pi is already there on the right side. Plus pi by 2 upon coming to the right side become minus pi by 2. So pi is common, that is taken out. What remains is n plus 1 minus half. N plus 1 minus half is n plus half. N plus half pi. This half, as you may guess right now, or if you are interested, you will be definitely guessing this corresponds to the 0 point energy of this kind of systems, and you can have this formula if and only if you compare with this one. That is why I have taken a modified reduction formula for 180 minus theta, or say pi minus theta. So 1 by h cross integral x1 to x2 pd x prime is equal to n plus half pi. That is integral x1 to x2 pd x prime equal to n plus half pi into h cross. H cross is taken to the right side. That is integral x1 to x2 pd x prime equal to n plus half. H cross is h by 2 pi, so pi vanishes. This is half h. Let me multiply this equation by 2 because I am not interested in this 2 on the denominator of the right side. So this becomes 2 integral x1 to x2 pd x prime equal to n plus half h. But twice this quantity is this one plus this one. So integral x1 to x2 pd x prime plus integral x1 to x2 pd x prime equal to n plus half h. That is integral x1 to x2 pd x prime. We make use of the result. If you change the limits from upper to lower, you will have to put a minus. Integral, so minus is put here. Integral x1 to x2 is modified as integral x2 to x1 pd x prime. What does this means? Integral x1 to x2 pd x prime, you are evaluating the integration from say x1 to x2. So x1 to x2 is the positive movement direction. Minus integral x2 to x1 pd x prime means you will be returning back like this. Dx in this case is negative. So minus and this dx negative will be absorbing to make it say positive upon your evaluation. So this include integration from x1 to x2 and back. That include the integration over a complete cycle or a complete period of operation as long as the bound state or bound system is concerned, and is represented by a closed integral. So closed integral pdx equal to, there is no modification for the right side other than the vanishing of these two. So all these terms will have the same right side, n plus half h. For closed integral pdx equal to n plus half h. This is the result that we obtain for the bound state. Closed integral of momentum, and this momentum can be written as p equal to square root of 2m into E minus V, where E is the total energy. What is so significant with this total energy? Potential energy will be always known to us, or in general, at least in the case of non-problems, the potential energy will be known. Or once you know the potential energy, then only we will be going behind such a quantum mechanical system. And our primary aim is to evaluate the energy eigenvalue. You have the energy eigenvalue in this expression. So this evaluation will definitely give you a method of evaluating the energy eigenvalue of the system under our study. That is the prime important parameter as long as a quantum mechanical study is concerned. So this is the fundamental result that you can have as long as a bound system is concerned. Closed integral of momentum over one complete cycle, or over one complete oscillation, or over one complete period of time domain is equal to n plus half h. This corresponds to the Bohr-Sommerfeld quantization rule of the old quantum theory. Bohr-Sommerfeld quantization rule, or the modified Bohr-Sommerfeld quantization rule, which is in fact a manifestation of the Wilson-Sommerfeld quantization rule. Wilson-Sommerfeld quantization rule is integral pdx over one complete cycle of dynamics equal to n times h. Half is not there in Wilson-Sommerfeld quantization rule. However, in Bohr-Sommerfeld quantization rule, you can have this half corresponding to the 0 point energy. And in the modification for the reduction formula for 180 minus theta, I have told you that it will be starting from 0 onwards. When n equal to 0, this energy must correspond to half h times some constant that you can have upon the evaluation of this integration. So this gives you a better approximation and a better result, or a more quantum mechanical result as long as the mathematics is concerned. And it's an important question as long as your examination also is concerned. There are only one confusion about this topic as long as the question setter is concerned. That is whether this is to be kept in short answer or in essay or in problem. So take care of this fellow. This is referred to as for this rather than referring. There is a little modification for Bohr-Sommerfeld quantization rule. This corresponds to the Bohr-Sommerfeld quantization rule of the old quantum theory. And the instrumental part of this formula is that this gives you a mathematical tool for evaluating the energy eigenvalue of the system under your study. Now we have started with the wave function, so we'll finish the story that the wave function will be able to tell us. The wave function representing the system in region 2. Why don't you take the wave function representing the system in region 1? Because in region 1 you cannot expect such a bound system. Bound system will be limited within the boundary of this potential in terms of the fact that in the region where the potential energy is less than the total energy. Of course, there is a probability for finding the system beyond this limit, which is a quality of the, or a property of the quantum mechanical wave function. So most often you can have a greater probability for finding the system in this region. That is why we are interested in the wave function in this region 2. So phi 2 is equal to 2a1 by root p sine of 1 by h cross integral x1 to x p d x prime plus pi by 4. Normalization require norm square equal to 1. So squaring this or taking the scalar product of this one with itself, you have 2 into 2, 4 a1 square by root p into root p, that is by p is written here sine square. I might not have made this kind of an argument. Sine square will have an average value over half a cycle, that